Hello, my name is Mustafa. Welcome to Lab 101. Now we are going to talk about one-way ANOVA and what it is. One-way ANOVA, normal distribution. We have our assumptions here: normal distribution, no outliers, and equal variances. As I said, I will ignore random sampling since we are working with natural sciences. So let's inspect our data, independent samples. We have copper, aluminum, and gold wires. These are three groups, and this is the independent categorical variable. And we have as dependent variable, we have the resistance values. So let's see if we meet the assumptions or not. I take my data as always, check for normal distribution like this. I stack over top of each other so that it's easier to use the calculator. In statistics.com, I select all of my data here. I come to quick statistics calculator. No, not that. Comma grow normal tests. And where is it? Copy it. Nice. And calculate. We see that our data is normally distributed. How can I say that? I put it here. We know our alpha is always 0.05. Let's see our hypothesis. P is larger than 0.05, so we accept the null hypothesis, so the data is normal distributed. We know that our data is normal distributed, so let's see if we have any outliers. We met our first assumption. So I come to descriptive statistics, percentile calculator, your data. I'll take my data from here, select it, place it here, calculate percentiles, and let's see, 0.454 and 1.25. Let's see, the interquartile range is Q3 minus Q1. Yes, the lower limit is calculated by Q1 minus interquartile range multiplied by 1.5. And I come to upper limits, Q3 plus the interquartile range multiplied by 1.5. So our top value is 2 point like this. Let's see if we have any 2's. No. And we don't have any minus values, so we can say that we don't have any assumptions. We don't have any outliers. So we'll need to check for equal variances. So how can we do this? I come to the calculators. And Levin's test for homogeneity of variances. So equal variances will test for variances. We have two of these. Interesting. Let's see if this has one. Come to home. Let's do this. Let's do with this one. I don't change anything from here. It's the same. So let's see. Group 1. We have as our group 1 the copper wire. Let's place it here. Let's remove the spaces and this one as well. And I place it here by this. Let's see we have equal variances. Calculate, and p-value is 0.779. Let's see. I have it here. Alpha value is 0.05. Let's see what's the hypothesis for Levin's test. There's no difference in variation between the groups. So we don't reject, since our p-value is larger than alpha, we accept the null hypothesis, so there is no difference in variation between the groups. So our data is homogeneous as well after doing this test. So since we meet all the assumptions, we can do test of one-way ANOVA. Let's come to our calculator. this is in the description box below. So if you click it there, you'll see. If you don't want to do it from here, you can do it from this part as well. It's easy. Just do the same thing. Let's see, one way ANOVA. You can do it from here. You don't need to change any of these. This is excluded, and yeah, you can just type your data here. But I'm going to use this site. So, including 2K, it says one way ANOVA calculator including 2K HCD. 2K values are for post-hoc. So I'll explain post-hoc when we come to it. First, let's see our data is significant or not. I come to here, come to here, bam, place it there, calculation. Let's calculate. And P is really, really small. So we say that for ANOVA hypothesis, since P is really small, we'll reject the null hypothesis. There's no significance between the means of groups. We'll accept H1. So we say that at least one of the groups is different, significantly different from the other two, but we don't know which one. So let me explain. When I take the average, the test as well, the ANOVA test does the same thing. It takes the averages and with some mathematical magic, it compares these values to see if they're significant or not, significantly different or not, these three values. We know that one is different from the other two, but we don't know which one it is. So we'll need to check the post-hoc statistics. I come to here. So when we compare the group 1 T1 and group 2 T2, we get a really small p-value. We don't even see the numbers here. It's really, really small. So let's see. Really small p-value. P is really, really small. And alpha, we know our alpha is 0.05. Let's see for post-hoc tests. What do we do? Post-hoc test, we reject null hypothesis and accept H1. There is a statistically significant difference between the two groups. So we know that there is a statistically significant difference between copper wire and aluminum wire in terms of changing resistance. We compare T1, T3 as well. They're significant. So gold wire and copper wire have a difference, and we know that aluminum wire and gold wire have also significant difference. But this is not enough to complete our IA. We know that all three are different in terms of their resistance, but we don't know which one is higher. Yeah, you can probably tell by this, but there's a more official way of doing it. So I take the averages, but we'll need to graph it with a bar graph. We'll do a bar graph like this, and we'll take the standard deviations. I write standard deviation. I will not use P. I will use S like this. Select like this as well. Bam. And we're going to draw the graph like this. So I'll select these three boxes and then the three up above with pressing control. I don't know what's for how to do it in Mac. I come to bar graphs, 2D column. I have my graphs here. And also I want to add my error bars as well with our standard deviations. More options. So let me show you how did I do this. Sometimes the chart doesn't show like the plus value here. So if you cannot see plus, just shake it around a bit and place it. You'll see plus. And I come to error bars. I take it. I come to this little arrow here. I come to more options. I come to custom, specify value. Let's see. I'll delete one from here and I'll select these three values, and I'll delete one from here and I'll select these three values as well. So let's see how can we read this. So if the error bars overlap, we say that there's a not significant difference between the means, but we see that the bars do not overlap, so we can see that there's a statistically significant difference between aluminum wire, copper wire, and gold wire via the graph as well. But also via with the graph, we can see that these three, like these three, which one have the uh, largest resistance, which one have the least resistance. While you graph it, you want to write exercise titles as well. So you'll need to write the exercise titles. And what do you need? You don't need any of these. Legend. No, trend. You won't need trend line. For bar graph, you'll need axis titles. You probably won't need your chart title. And I just clicked on it and pressed space backspace, and you can use your graph like this. You'll need to label it like this is resistance with its value. I don't know what it is, and if it's uncertainty, you also do wire type. You won't need any units for this or uncertainty since it's categorical, and you're done. You can write your internal assessment like this, or do whatever you do. Thank you for watching.